Okay, part 2. Finding the inverse of a function defined by ordered pairs. Well, as I mentioned in class, if we have a point 3, 1, the inverse on the graph would be at 1, 3. So consider the arrow diagram on the previous page, and it says here the function which maps from A to B can be described by the following set of ordered pairs. So 1, 2, 2, 4, and so on. So 2, 4, 3, 6, and then 4, 8. So the inverse function which maps from B to A, notice what happens is the points get turned around. 2, 1, 4, 2, 6, 3, and 8, 4. So that's what it says here. Notice that the ordered pairs for the inverse can be obtained by interchanging the first and second coordinates of the ordered pair of the original function. This reinforces the rule that the domain of the inverse function is the range of the original function, and that the range of the inverse function is the domain of the original function. Just swapping x and y values. Okay, so let's clear that and move down to the next example, example 3. And it's saying here, consider the function defined by the following set of ordered pairs. Describe the inverse of the function by a set of ordered pairs. So the inverse, they're using curly brackets and putting all the points in there. The inverse would be, points on the inverse would be -2, -4, and then -1, -2, and 0, -1, and 1, 0, and 4, 2, and 8, 3. Graph the original function and the inverse. So in other words, graph these points. So -4, -2 down here, -2, -1 would be here, -1, 0, -1, 0 would be here, and 0, 1, 0, 1 would be here, 2, 4 would be here, 3, 8 would be up here. This graph looks like it's curving. Let's just check 4, -2, -4, -2, and then -2, -1, -1, 0, 0, 1, and then 2, 4, yeah. So let's just graph that with a line. We see that it's going through these points, like so. Whoops, I missed that one. Okay. And now if we graph the other one, let's change the color here. Whoops. Try that again. Let's see. Go to red. -2, -4. -2, -4 is down here. Oops. Oh, sorry about that. Just went down a page by mistake. Okay, I think we have it there. Have we? There. So, using red, we will plot -2, -4. -2, -4 is here. We have -1, -2. We have 0, -1, 0, -1. We have 1, we have 1, 0, we have 4, 2, 4, 2, and we have 8, 3. And plotting those points, we get this curve like this. And so on. That will continue down, I guess. So you can see they are a reflection of each other, and I think I accidentally moved this graph. Want to move the page there. This should really go through this point here. 0, 0 should be about here on the graph. So graph and then draw the line which acts as a mirror. Well, the line acts as a mirror. We just page down here slightly. I'm going to just move this till I get to 0, 0. It's kind of tricky moving by fractions here. It's not really working to my satisfaction, but if we're graphing the line, we'll take green here, but basically going through all the points where x equals y, which I can't draw a straight line because I don't have a ruler. Okay, so basically if I have the line y equals x or x equals y, I can have a mirror image so let me just clear this first of all. I can have a mirror image. Here's your y equals x. Okay, I redrew this original order of pairs here, and then the red was the inverse. So here we have the original and the red inverse, and the mirror line is the line we know as y equals x. So that's what they're asking for down here, y equals x. Okay, so I'll just pause for a second. Alright, so finding the inverse of a function defined by a graph. It says here, like I mentioned in class, determine the inverse of a function. You can reflect the graph of the function in the line y equals x, or alternatively select the coordinates of some key points on your graph and interchange the coordinates and plot the new points. So here we have some examples where we're going to sketch the graph of the inverse of the functions defined by the following two graphs, and it's asking, are these functions, is the inverse a function? So let's take some key points. They have them here for us. This looks like, now look at the scale here, every box is 2. So this is -6, 0. So that becomes 0, -6, which in fact happens to be this very point. So we have a new point right there, and we can just circle that in blue. This point, well, guess what? It ends up over here, because this is 0, -6, which ends up at -6, 0. How about this point? Well, this point is 6, 0, so that ends up at 0, 6. So you can see the new graph is going to go like this, all the way along here, and in that direction. And that's going to go up and up and up in that direction. Okay, is this a function? No, because a vertical line through can tell you that that's not a function. Okay, in this one, again we can take some key points right here. This is similar to this point, in fact. We are at -6, 0, so 0, -6 is here. We are at 0, 4, so that becomes 4, 0 right here, and this is 6, 0, so 0, 6, the other point here, and we end up with a similar graph, and it will look something vaguely like that. Now, is that a function? No, because again, a vertical line test goes through it more than once. Scrolling down, finding the inverse of a function defined by an equation algebraically. Algebraically, we're going to find the equation of an inverse. Now notice if we're changing the x and y in the points, we can do the same in the equation. Interchange x and y in the equation, and then we want to resolve for y, because we want the final equation in a form that says y equals. Consider this function defined by y equals 3x plus 2. Find an equation in the form y equals mx plus b for the inverse function. Sorry, just clear what I had there. So all you're doing is just switching the x and y. So the equation becomes x equals 3y plus 2. Now we want to solve now for y. We want to rearrange this and solve for y. Okay, so let's leave 3y here. We're going to bring this 2 over, so it will be x minus the 2 on the other side. Simply all we have to do now is divide both sides by 3, and we'll solve for y. So we're rewriting that, y equals x minus 2 all over 3. Graph the original and its inverse on this grid. Well, we know what that looks like. It's a straight line going through at 2, slope of 3. So we rise by 3, 1, 2, 3, and run by 1. Or we can go back 1 and down 3. It's another way to do it. Back 1 and run 3 will get us to approximately here. And so on. So that would be another point. So we have this line coming down like this. Okay. Now the inverse of this function we could reflect, or we can take significant points. Something like this one here. I'm just going to change colors, make it red. So this will get reflected over here. This point is -1, -1, which stays. We'll reverse them, that'll stay there. And again, this slope, instead of having a slope of 3, it's going to have a slope of 1/3, I believe. In other words, up by 1 over 3, up by 1, next one is over 3, and so on. That's another way to manage the points and sketch the graph. So 1, 2, 3, where are we? 1, 2, 3, and down by 1. We're going to end up somewhere down here. So our line is going to look like this. Okay. And notice the line y equals x is going to run right the way through here in the middle. I won't draw it. Okay. Is the inverse of the function defined by this also a function? Yes, this line here is a function. So I'm just going to look to see what we want here. Okay, so I'll just pause. Sorry, one thing I didn't do here was to actually answer this question, find an equation for the inverse. Oh, sorry, I did do that, didn't I? Okay, so what was it? It was the y equals x minus 2 over 3, I believe. Now another way to write this, if you want, is that you can divide both the x and the -2 by 3. So y could also equal 1/3 x minus 2/3. And they wanted us to write it in that form here. That's the part I missed out on. So slope is 1/3, crosses the y-axis at -2/3. Now, graphing the inverse of a function defined by an equation by calculator. These are the instructions here that show you how to do this on a calculator. Basically, you enter in your regular y equals your equation, press graph, you'll get the graph of that equation. To find the inverse, access the draw inverse command by pressing second and then program, scroll down to draw inverse and press enter. To draw the inverse of the function that you entered up here, press the button or the option VARS. Scroll to YARS, it looks like, and then to function and press enter. Press enter again, and the graph of the inverse of the function will be shown along with the original. So try that out. Enter in a regular equation, probably for a straight line would be the easiest thing. Maybe why don't you try something like the equation above, or whatever straight line you want to try. Now it says note here, if you only want to graph the inverse of the function and not the original, clear the y equals editor. Use draw inverse followed by the equation of the function, the original function, and then press enter. I believe that should work. I wouldn't bother about this here. Okay, class example number 6. Use the procedure to confirm the graph of the inverse in class example 4a, and the original graph has the equation y equals absolute value x minus 3. So use this above procedure to confirm the graph of the inverse in class example 4a. 4a was it doesn't actually, oh well, this, yeah, 4a is actually a graph and this was the equation of that graph. So see if you can check out, if you turn back a page, you'll see what we got, or look at the video a few minutes back and we'll see what we got for the graph, for example 4a. You should be able to graph it on your calculator using this, and then use the procedure above, up here above this note. Use that procedure to draw the inverse as well and confirm that it's exactly the same as example 4a. Okay, so if you would complete examples 1 to 11. Let me just check if there's anything you want to skip here. Now, as you go along, if you're finding it quite simple, I would just skip and just do maybe odd letters for number 6. Do A and C perhaps for number 7, and then do all the rest. Okay, so number 5 is a long one, but just do the odds of number 5 and the odds. Sorry, number 6 is the long one. Do the odds for number 6 and the odds for number 7. Do all the rest. Okay, hopefully that was helpful, and we'll see you tomorrow in class.